Hey everyone, this is Anirudh from Edureka. In this session, let me walk you through Python in this detailed tutorial, and I'm sure you guys will have lots to take away from this session. Well, this session is intended to be useful for anyone considering to kickstart their learning about Python and need some insight about the language. The focus is to basically approach the language in the easiest way possible and to find out what it has to offer for the community and all the learning enthusiasts out here. Well, let's begin by checking out the agenda for the session, guys. We'll start with the introduction of Python and later move to installing and working with Python as well. Followed by that, we'll be looking at the overview of the concepts and to learn how easy it is to actually code with Python. And at the last, we'll take a programming approach where we learn the concepts directly through code. And I believe that that's better and that's easier to understand Python as an overall language, guys. So let's begin by checking out what Python actually is. So we already know that Python is a language, right? Well, to be more specific, Python is a really powerful high-level object-oriented language which was created by a person called as Guido van Rossum. Well, yeah, that's him. So why didn't he choose to name this as Python? I'm sure you guys are curious. Well, it is not certainly because of the snake, but it was from a TV show that Rossum used to watch. Well, that's a fun fact. So let's get started then. I'm sure you guys are curious about why Python is so popular, right? Well, if you can recall a few years ago, people told Python was the next big thing. Well, they were true. In today's situation, it definitely is the big thing. So what do you guys think? So let's check it out. Well, for starters, we all feel a little bit let down, or we feel that we are lacking when we start learning new languages, right? So whether you're a beginner or a pro, it's maybe because of all the sheer concepts or something that confuses you or doesn't give you a good picture in that language. Well, in my personal opinion, Python solved all of my headaches with all the languages that I have learned, and if I had to start over again with the language from scratch, I would definitely choose Python for sure. No two thoughts, guys. It is very beginner friendly and the syntax is extremely simple to read and follow through as well. This definitely makes us all happy, and surely yes, Python has millions of happy learners across the globe, guys. I can't begin to tell you how fun it is to work with Python, and I'm sure you guys will appreciate the language after this tutorial as well. So as popular as it is, there are some unique features of Python as well. So let's walk through all the unique features of Python. Well, to start out with, it's a really simple language which is easy to learn. Guys, Python has a really simple and an elegant syntax. It is so much easier to read and write Python programs when compared to other languages like C++ or say Java or C#, right? So Python makes programming real fun and it allows you to focus on the solution rather than the syntax itself. And if you're a newbie, it is a really good choice to start your journey with Python. Secondly, it is free and open source. Well, yes, you can freely use and distribute Python, even for commercial use as well. Not only can you use and distribute softwares written in Python, but you can actually make changes to the Python source code itself. So Python has this large community which is constantly improving it in every iteration or every version as it is. And thirdly, it definitely has to be portability, guys. You can move Python programs from one platform to another and run it without any changes at all. It runs seamlessly on all of the platforms including Windows, Mac OS and Linux as well. And next up, it is extensible and embeddable. So what do we mean by that? So suppose an application requires high performance. You can easily combine pieces of C, C++ or any other languages with Python code as well. This gives your application really high performance capabilities as well as scripting capabilities which other languages may not provide out of the box. And next up, Python is a high-level interpreted language, guys. So unlike C, C++, you don't have to worry about daunting tasks such as memory management or garbage collection and so on. Likewise, when you run Python code, it automatically converts all your code to the language that your computer understands, and you don't have to worry about any of the lower level operations as well. So moving on, Python has support for large standard libraries which are used to solve common tasks as well. So Python has a number of standard libraries, guys, which makes life of a programmer that much easier since you don't have to write all the code for yourself. Let me give you an example. Consider this. So let's say you need to connect the MySQL database on a web server, right? So you can use the MySQL DB library using just the syntax of import MySQL DB. And the standard libraries of Python are all well tested and it is used by hundreds of people. So you can be sure that it won't break your application, and it is as simple as this. And lastly, it definitely has to be the object-oriented language, right? So everything in Python is definitely an object. Object-oriented programming concepts help you basically to solve a complex problem intuitively. And you're able to divide these complex problems into smaller sets by just creating objects, guys. It is as simple as that. And now that you know the features of Python, let's take a look at why you should consider learning Python. Well, Python is a general purpose language, guys. It has a wide range of applications from web development using, say, Django and Bottle and all of that, and scientific and mathematical computation using Orange, SymPy, NumPy, etc., to desktop graphical user interfaces such as Pygame or Panda 3D as well. The syntax of the language is really clean and the length of the code is relatively short. It is really fun to work with Python, as I keep mentioning, because it allows you to think of the problem rather than the syntax, and this is really important, guys. So are you still not convinced? Well, let me give you 4 more concrete reasons, after which I am sure you'll begin to learn Python really easily. So Python programming is fun. It is easier to understand and write Python code as well. Why? Because the syntax feels really natural. So take the source code for an example. Even if you have never programmed in your life before, you can easily guess that this program adds 2 numbers and just prints the sum, right? So it is as simple as that, guys. So moving on to the next big reason. So guys, you don't need to define the type of a variable in Python. Also, it is unnecessary to add a semicolon at the end of the statement as well. So Python basically enforces you to follow good practices like proper indentation, for example. These smaller things can make learning so much easier for beginners, in my personal opinion, guys. So the next reason is, guys, Python allows you to write programs having greater functionality with fewer lines of code. You will be amazed at what you can do with Python once you learn the basics. There is an entire tic-tac-toe game which is less than 500 lines of code totally, which is really cool, right? So moving on, Python has a really large supporting community as well. There are numerous active forums online that can be handy if you're stuck. So guys, at Edureka, we have a vast community for Python, lot of blogs, and these amazing videos curated by our subject matter experts as well. So make sure you check them out. So next up I have for you guys is the installation of Python. It's really simple and straightforward, so let's begin. So guys, there are about 5 to 6 steps and it's really simple, so let's check it out. So to start out with, you need to go to the official Python page on the official site and click on download Python version 3.6. However, if there are new versions of Python as well, please consider downloading the latest stable version as well. And next up, when the download is complete, all you need to do is double click the file and follow the on-screen instructions and install it. However, do note that when Python is installed, there is a program called idle which is also installed with it, right? So it provides a graphical user interface to work with Python. And to create a file in idle, all you have to do is go to File, New Window, and create a file. As simple as that. And write your Python code. To save it, there's a shortcut which is Ctrl S. And you can save it with the .py extension, which is an extension for all the Python files. And lastly, you need to go to run your module, and you can see the output as well. So guys, there's another way to do this as well, which I'll be walking you through in a while. So we'll be making use of this online platform called as Google Collaboratory. So basically, Google Collaboratory is nothing but a Jupyter notebook hosted on its clouds. So you can save the code instantly, it'll save on your drive and you can carry the code wherever with you, right? It is really simple and you don't have to install anything. It's all there, it's all ready, and it's waiting for you to write some Python programs in it. And now that you've followed these steps and installed Python, we need to check out some of the development environments, or IDEs for short, that we can use to code Python in. Well guys, we have PyDev for Eclipse, we have PyCharm, we have Notepad++, and we have Bluefish for your Mac users as well. Well, we have Komodo and Vim too. These are some of the many IDEs out there that can be used to develop code in. Well, I suggest you use something that you're comfortable with and go on from there. So we have the environment set. What's next? Well guys, we need to check out a little bit about what's compiling and interpreting as well. So consider the diagram on the screen. Well, Python is definitely directly interpreted into machine instructions, but what is the process of compilation? So let's say we have a source code in Java. So let's call this as hello.java, right? Java is the extension. And this gets converted into bytecode, which then becomes hello.class. And hello.class is actually run on any machine to get us the output. So this is compilation. So with interpretation, guys, it is a little bit different. So let's say the source code, right? We have hello.py in our case. Well, since Python is a directly interpreted language, hello.py is directly converted into the output and there is no execution phase in between, as you can see in the compile phase as well. So now that that's done, let us dive right into the heart of Python and let us check out some of the basic concepts, guys. Well guys, to make it easier for you, I'll be having a lot of text in this tutorials as well to make sure that there is a good readability and that you can follow through as well, right? So let's start out with expressions. Well guys, expression is a data value or set of expressions which is used to compute a value. any expression, right? So 1 plus 4 is an expression. 1 plus 4 into 3 is an exception, and eventually it led to an output. We have arithmetic operators such as addition, subtraction, multiplication, and division. We have modulus operator, which is used to calculate the remainder as well, and we can exponentiate as well. So guys, we'll be walking through this in detail in the next slides. Next up is precedence. Well, precedence, as the name says, is the order in which the operations are computed. Well, multiplication, division, modulus, and exponentiation have a higher precedence than just addition or subtraction, guys. So 1 plus 3 cross 4 is 13, right? Well, consider this. Parentheses can be used to force a certain order of evaluation. So let's say 1 plus 3 is put under parentheses, right? So the overall value becomes 16 and not 13. So this is why precedence is really important, guys. So next up, let us check out some of the basic math commands that Python provides for us. Well, to start with, we have something called as ABS. ABS is nothing but the absolute value of it, right? Next, we have ceiling. Ceiling basically rounds up a number to its next number. So if we have 1.5, the number becomes 2. And next we have the cosine function. This will give you the output in radians. So make sure you note that. And next is floor. Well, floor is the opposite of ceiling. And we have logarithmic value. We have logarithmic to the base 10. And we can find out the maximum and the minimum between two values as well. And we can round the value to a nearest whole number. So let's say your 1.9 can be rounded off to 2. Your 1.1 can be rounded off to 1. So you'll have to make use of the math command round and put in the value as the expression. And we have sine as well. So the output again is in radians as we discussed. And we can find out the square root using sqrt as well, guys. And there are some good constants that Python provides us. So for example, E is 2.718 and the value of pi as well. It is 3.1415 and so on. So now that that's established, let's move on. So next up, we need to look at what variables actually mean. So guys, variable is a named piece of memory that can be used to store a value. How do you use variables? Well, let's say you compute an expression's result, right? And you store that result into a variable. And the overall goal is that you actually later make use of that value stored in the variable. For example, consider an assignment statement. Assignment statement is used to store a value into a variable. So left-hand side is the name followed by the value in the right. So consider that example on your screen right now. So we have x is equal to 5 and GPA is equal to 3.14. As you could have guessed it, x is the name and 5 is the value. Same goes with GPA and 3.14 as well. So a variable that has been given a value can be used in any of the expressions. So consider this, guys. Instead of directly doing 5 plus 4 as 9, you're going to substitute that 5 with an x. So x plus 4 is also 9 as well. And moving on, we need to take a look at the basic data types, guys. There are many data types that Python provides us, and let us consider a few. So let us start out with integers. Integers, as the name suggests, is the default for number, guys. So z is equal to 5 by 2 will not make sense to you directly. Why? Because z is equal to 5 by 2 as we know that it is 2.5. But if it is an integer, everything after the floating point is discarded. So 2.5 becomes 2. So if z is a variable of the type integer, 5 by 2 will give you an output of 2 and not 2.5, guys. And consider this. Next up is float. Float is nothing but floating point, guys. So it does the opposite of what integer does. So consider this. So x is equal to 3.456. So do the values after the floating point vanish? No, that's the entire point of floats. So next up is strings, guys. You can either make use of double quotes or single quotes to specify with ABC is equal to ABC because they both are the same, right? And there can be an unmatched string as well. So consider we have something called as Mats. And Matt is a person, and let's say we want to talk about Matt's pen. Well, there is an apostrophe there, right? And this is an unmatched expression. Well, that can be used as well. So guys, do note that we can use triple double quotes for multi-line strings or strings that contain both single and double quotes in them as shown below. And now that that's set, we need to take a look at something called as whitespaces, guys. So whitespace is nothing but a blank space. And it is especially really important in Python because of the indentation and the placement of new lines. And guys, make sure to use a slash when you must go to the next line prematurely as well. And no braces or any other thing works to mark the block of code here. So guys, only constant indentation is really important. Well, the first line comes with less indentation, it defines that it is out of the block. And the first line with more indentation starts at a nested block as well. So it means that it is inside a block. Also guys, do note that colons start a new block in many constructs as well. For example, function definitions and clauses, and I'll be walking you through these in the next slides as well. And I'm pretty sure you guys are curious about how we can put in comments, right? So basically, comments in my opinion are really important. Well, in fact, it is as important as the code in my opinion, right? So comments really help us understand the code better. Well, we can add comments with putting a hash before the comment. When you do this, the rest of the line gets completely ignored. You can also include a documentation string as a first line of a new function or a class that you define as well. So development environments, debuggers and other tools can use it too, guys. It definitely is a really good style to include a comment as well. So as you can check out, we have a hash which says I am a comment. So that definitely is a comment. However, you can have a comment with spaces as well since the entire line is ignored. And now that you're one step closer to learning Python, let us check out what assignment statements actually are. So guys, how do you put a value in a variable as we previously discussed? Well, binding a variable in Python means that just you set a name for something and that holds a reference to an actual object which is present elsewhere, guys. So assignment creates references and not copies. Guys, it would be really good if you actually note down these at this point so that you won't get confused in the later part of the tutorial. And names in Python do not have to be in intrinsic types. Objects have types for that matter. Well, Python determines that the type of the reference is automatically based on what data is assigned to it as well. You can create a name the first time it appears on the left side of an assignment expression. So x is equal to 3. At this point of time, a reference is deleted via the garbage collection after any names are bound to it which are passed out of scope as well, guys. So Python makes use of reference semantics as well. Well, more on this later, guys. So that was a quick introduction. So let's take a quick break. Let us check out who uses Python, right? So guys, everyone from Google, NASA, IBM, Mozilla, all the way till Netflix and even Dropbox for that matter, right? So these are all the big players which make use of Python on a daily basis and they've integrated Python code into almost all of their apps that we use. So that's really a good thing. So now that that's done, let's quickly get back to something called as the naming rules. So guys, we don't have any major rules for that matter, but we do have some important things. Well, you need to watch out for something called as the reserved words as well. More on that in a second. Well guys, names are case sensitive and you cannot start a name with a number. So make sure you note that. And they can contain letters, numbers and underscores as well. So all of the cases are valid cases which are shown there, guys. And there are some reserved keywords as and, assert, break, class all the way until try and while. Well, you cannot make use of these as names of the variables as that will pop out an error and the Python interpreter will tell you that you're using a reserved word for a variable, right? So more on naming in a second, guys. So basically we have 3 recommended naming conventions. And the Python community has basically set these recommendations to make our lives easier. We have something called as joined lore for all the functions, methods and the attributes. And we have something called as all caps as well. So you can have all caps for your variables and your constants as well. And studly caps is something we use for classes as well, guys. So attributes say such as interface, underscore internal, underscore private, all of these are valid. So now we're familiar with all the naming concepts, right? So let's move on to check if there is an easier way for assignment. Well guys, so basically less of typing definitely means more of coding, right? So you can assign multiple names at the same time. Instead of typing x is equal to 2 and y is equal to 3 and then printing them out, all you can do is x comma y is equal to 2 comma 3, where x gets the value 2, y gets the value 3. And this definitely makes it easier to swap values as well. All you can do is x comma y is equal to y comma x. So x value is y's value now and y's value is x. Also, the assignments can be changed as well. So let's say you want a and b to have the value of x. So a is equal to b is equal to x will make sure that all the values of a, b and x are is equal to 2, guys. It's as simple as that. So guys, moving on, what happens when we access something which is non-existent, right? So let's see how we can raise an error of our own. So accessing a name before it's been properly created will raise an error for sure. So let's say we've been working with x and a, b, right, in the previous example. So let's just go ahead and print y. But as you can see, it says name y is not defined. But when you define y is equal to 3 and try to print out y, Python knows that y exists and there is an object which is referenced there and Python will print out 3 for you guys. And now that that's done, there is something called as casting. Well guys, this is a really simple concept and this will help you a lot down the line. So guys, consider this. There may be times when you want to specify a type to a variable, right? So this can be a conversion of int to float or float to int as well. Well, this can be done with casting, guys. Python is an object-oriented language and as such, it uses classes to define data types including its primitive types as well. Casting is really simple and we'll be checking out the example in our use case. But to just give you a better clarity, make sure you check this out, guys. So we have x is equal to int of 1. So x will definitely be 1. We have y is equal to int of 2.8. As I told you, once it becomes int, everything after the floating point goes away. So y now is actually 2 and not 2.8. Z is equal to int of 3, definitely will stay at 3. So now let's consider float, guys. Well, x is equal to float of 1. Well, in this case, it's a little tricky because there is nothing after the floating point here, right? So basically, Python attaches zeros for us when there is nothing after the point. Float of 2.8 will remain 2.8. Float of 3 with quotes, as you can see, will remain 3.0. And float of 4.2 with quotes will be 4.2 as well. So guys, next up we have something called as strings, and I'll be walking you through strings in the detail in the next few slides. So consider this. Well, x is equal to string of s1 will be s1 as well. Y is equal to string of 2 will convert the number into a string. Well, to explain strings in the easiest way possible, consider a string to be a message, guys. So guys, 2 here will go from a numeric value into a string value. And it is the same thing with 3.0 as well. It will be converted into a string. And all of these is explicitly converting because you're actually mentioning it with int, float, and strings. So I'm pretty sure at this point we have had a lot of theory, right? So let's move on and let's start coding, guys. I'm pretty sure Python is really easy to learn, and especially you can do a lot with Python when you actually practice and when you go about understanding the syntax as well. The syntax is really simple, so let me start. I'll open up my Google Collaboratory and we can start there. So guys, as I told you, we'll be talking about strings for now. So let me just go ahead and connect to my Collaboratory. So at this point, it is basically assigning us a kernel and a data space, so where we can work with, right? So there we go, now that we're connected. So let's get started with strings. As I previously mentioned, hello with double quotes is same as hello with single quotes. And square brackets can be used to access the elements of the string. So consider we have a string called A. And we have assigned A is equal to hello, comma, world. So what do you think happens when we print A of 1? Can you take a guess? So let me go ahead and run it for you guys and we'll see what comes, right? So definitely A of 1 is pointing to E. Well, why is it pointing to E? Well, E is the second term, HE, right? HELLO, E comes second. Well, why is Python pointing out to a second term when it is 1? Well, do remember that Python indexes everything from 0 and n minus 1. So instead of doing it from 1 to n, Python starts it from 0. So H becomes 0 and hence A of 1 is E, guys. It is as simple as that. Next up, let us check out substrings, guys. Well, you can get the character from any position to any position. It may not be 2 to 5 as I've shown in this example, but do know that the numbers you put in will not be included. So in this case, we'll be pulling out the characters which are from the position 2 to position 5 without 2 and 5 being included. And this is really important, guys. So let me go ahead and run this. So as you can see, we have L, L, and O. Position 2 is included, but position 5 isn't, guys. So that's simple. Next up, we have a lot of methods we need to discuss, and I'll make it easy for you guys as well. As you can see, there is a lot of text and you can follow through as well. So guys, we have something called as a strip method. Well, what is a strip method? So it basically removes any white space from the beginning or the end as per your requirement. So as you can see, we have A equal to double quotes. We have a white space. Again, the same with world as well. So as soon as we run the strip method, it will remove that white space for us. Guys, we have another method called as len, which is used to return the length of a string as well. So we'll be printing len of A for that. And as soon as we print it, we're going to have a value of 13. So Python here is telling that our string is of the length 13. So 13 characters, guys. And next, we have something called as a lower method, which is used to convert a string to lower case. So here we have hello world, right? H and W are in caps. So as soon as we convert it to lower, H and W will be pushed to lower case, as you can see that. Similarly, we have the upper method as well. All the uppercase will remain uppercase and all the lowercase will be pushed forcefully into uppercase as well. We do that by using a.upper as shown here. So let me go ahead and run it. As you can see, everything is in uppercase now, guys. But what if you want to replace one string with another string? Can you replace something in hello with something else? Well, yes, we can. So basically, we'll be replacing the H in hello with a J. So hello should become something like jello. Let's go ahead and run that. Let's see if we can do it. As you can see, H became J and it says Jello World right now. You can replace anything with anything, guys. So make sure you map what you want to replace with what you want to replace it with. So next up, we have something called as a split method. Well, guys, split method splits the string into substrings if it finds out there are instances of a separator in between, right? So consider this A is equal to hello, comma, world. Well, as soon as we run split, we're going to run the split based on the comma. So as soon as our Python interpreter comes across the comma, it'll make sure to split it and make it into two strings as well. So go ahead and check this out. As you can check it out, hello and world are two lists. Well, what are lists? Well, we'll just start out with that. Before that, let's just move back to the presentation to see what's next, guys. Definitely, it has to be Python operators, and we need to learn a little bit of theory again. Well, what are Python operators, guys? Well, operators are definitely used to perform operations, right? And we can perform many operations with Python. So I'll have a few listed for you guys, and we will not require the code for this because it is really simple to understand and straightforward, right? So it is basically just time consuming to show you code for something that can be understood really easily without the code as well. So check this out. We'll be starting with arithmetic operators. And I'm pretty sure everyone here is familiar with what is going on, and I don't think I'll have to explain, right? So well, the operator is plus, is performing the addition operation between two variables x and y. Next we have the subtraction operation, we have the multiplication operation, we have division operation, followed by the modulus. Well, what is modulus? I'm pretty sure a few of you guys are curious here. Well guys, consider you're dividing 4 by 2, right? So as soon as you divide 4 by 2, we'll be taking the quotient. Well, what is 4 by 2? It is 2. But what is the remainder of 4 by 2? Well, in that case, it is 0, right? Here it was 0, but consider a case where the remainder was not 0 and you will require the remainder. Well, that is what our modulus operation gives us, guys. So it basically gives us the remainder instead of the quotient. And next up, we have something called as exponentiation. Well, what is exponentiation? Let me give you a simple example. 2 into 2 is 4, correct? 2 power 2 is 4 as well. Well, 2 exponential 2 is nothing but 2 power 2. 10 exponential 2 is nothing but 10 power 2. So basically it's the first number raised to the second number, guys. And lastly, we have floor division as well. So moving on, what are the operators we're checking out next? Well, yes, assignment operators, guys. So we have the operator equals to, where we've checked out the example where x is equal to 5. It is definitely same on the right hand side in this case as well. Next, we have something called as plus is equal to. So x plus is equal to 3 is literally same as x is equal to x plus 3. Well, instead of making it a long form of code, this is just a short form of code, guys. And minus is equal to is the same as well. Instead of typing x is equal to x minus 3, we can just type x minus equal to 3. Same for division and multiplication as well. And we have something called as shifting as well, and this operation holds good for shifting. And x shift equal to 3 is the same as x shift 3, guys. So I'm pretty sure you guys are getting all of this by now, right? Python is really simple. So let's check out what operators we have next. Comparison operators. Right, this is really easy and straightforward, guys. So we can check if the values between two variables are the same or not. Well, consider equals, right? So we can check if something is equal to something else. We can check if x is not equal to y. We can also check if x is greater than y, x is less than y, x is greater than equal to y, or x is less than or equal to y as well. So it's pretty much self-explanatory, and I don't think I have to dive into the detail of this, guys. So moving on, we have something called as logical operators. Well, what are logical operators? So basically it is used to combine the statements. So can we combine these statements? Definitely we can. So we have three operators, right? So we have AND, we have OR, and we have NOT. Well, with AND operation, consider this. It returns true if both the statements are true. Well, in this case, let us consider x to be 1. Is 1 less than 5 and 1 less than 10? Are both true? Yes, they are. So AND operator will return true for us. Next up is the OR operation. Well, it returns true only if one of the statements is true, right? So consider x to be 4. Is 4 less than 5? Yes, it is. Or is 4 less than 4? No, 4 is equal to 4 and not less than 4. But the first statement was valid. 4 is less than 5. So definitely it returns true as well. And NOT is something really simple. So basically it reverses the result. It returns false if your result is true, and it returns true if the result is false. So what do we have next? We have something called as the identity operators, guys. Well, why do we require identity operators? Well, we compare objects not to check if the values are equal, but to check if they're actually the same object. And we have two operators. One is and the other one is not. Well, it is pretty much opposite to each other, and let me explain. Well, is returns true if both the variables point to the same object and they are the same object. And is not will return true if both the variables are not the same object as well. It is as simple as that, guys. Moving on, we have something called as bitwise operators. Well, let's compare binary numbers and operate on them, right? So definitely, we have something called as AND, and obviously the symbol for AND is the ampersand. So what happens when we use a bitwise operation on an AND? So it sets each bit to 1 if both the bits are 1. And with OR, if you guys remember the logical constructs that we discussed earlier, it is pretty much the same as well. So it sets each bit to 1 if one of the two bits are 1. However, XOR is a little bit different. It sets each bit to 1 only when one of the two bits is 1. So there has to be a compulsion of only one bit having a 1 so that you get the output 1, guys. Just read through it and you'll get a better clarity on that as well. Not definitely inverts all the bits. So if it is 1, we get 0. If it is 0, we get 1. We have something called a zero fill left shift as well. So guys, consider a number. So by shifting left, what we actually mean is that we'll be pushing zeros in from the right and we let the leftmost bits fall off as the name suggests, guys. It is similar, but consider the right shift. Well, assigned right shift is done by pushing copies of the leftmost bit in the number from the left and let the rightmost bits fall off. It is as simple as that. So now that we've checked out all the operators, we quickly need to head back to our code to check something called as lists. Well, lists are really interesting and you'll be using a lot of lists for learning as well, guys. So let's just head back to the code and check out lists. So guys, what is a list? Well, a list is just a collection which is ordered and changeable. It is just a collection, right? It allows duplicate members as well. So we'll be using square brackets for this and all of the elements are separated by commas in the inside, guys. So make sure you check that out in the code here. So we have something called as apple, banana and cherry here. These are fruits, correct? Yes. So these fruits are a part of our list. So basically it is a collection. So as soon as we print this, as you guys can check it out, we have apple, banana and cherry as separate elements as we defined, right? So how do we access items in a list? Well guys, you can access the list items by referring to the index number. Well, index number is nothing but the position number of that. If you can remember, I told you that Python indexes from 0 and not from 1. So to print the second number of the list, we're going to index the first value, which is 1. So in this list, particularly if you want banana, this list of 1 is needed. If we need to pull out cherry, this list of 2 in square brackets is required. So let me go ahead and print this and we'll have the output to be banana now. So let's move on. How do we change the item value? Well, to change the value of a specific item, all you need to do is refer to its particular index number, guys. So let us change the second item. Well, second item right now is banana, right? Let's make it blackcurrant. All we're trying to tell the variable is that take the banana out of it and put the blackcurrant in. So this is done by using, so as you can notice that there are square brackets of 1 in the left hand side now in this case, right? Which was not there earlier. So what this is telling the Python interpreter is that you want to go to the second element, you want to index the second element and then replace that with blackcurrant. So as soon as you go ahead and print this, we'll get blackcurrant instead of banana in the second element. So apple, blackcurrant and cherry. Good enough? So I'll be discussing loops in a while, but we need to know what loop through a text is at this point. Well, you can loop through the items list just by using a for loop. However, you will not know for loop at this point, but if you do, good enough, guys. So we have apple, banana and cherry. So for x in this particular list, print x, right? So as soon as we do this, we're going to have the output of a loop which is run through our list and we'll get the individual answers of it as well. As you can check out, we have apple, banana and cherry separately. And next up, we need to check if an item exists in that particular list. Well, to determine if a specified item is present in the list, we use the keyword in, guys, in. So let's check if the apple is present in our list. Well, to look at it, we can know apple, banana and cherry exists, right? But how will our Python interpreter tell this? Well, we can use something called as the if construct again, which is dealt in the next section, guys. So basically, if apple is present in list, print that this apple is present in the list, right? So it is as simple as that. So make sure you check out the indentation between the print and the if, guys. So there is a blank space here. So let me go ahead and run this. As you can check out, it says apple is the fruits. So what if I put something else here, guys? So instead of apple, let me just put apples, right? So I'm just going to add an S. So as soon as I run this, what do we get? We're not supposed to get anything at this point because our interpreter doesn't know what to do. Well, we told that if Python existed in this list, print something for us. We never told what it's supposed to do when apple isn't present there, right? So we'll be checking out if, else and all of these constructs in a while as well, guys. So make sure you stay until the end of the video. And guys, next up, we need to check out how we can get the list length. To do this, we have something called as a len method, which makes our lives easier again, as I told you. Well, as pretty much simple as that, all you need to do is pass this variable to our len function and it is going to give you the length. So as soon as I go ahead and print this, it is going to tell us 3. Well, what does this 3 indicates? It indicates that there are 3 elements present in our list, guys. So the length of the list is 3. And next up, can we add elements and remove elements? Well, we can add elements for sure. To add an element to the end of the list, we use append. So append is basically pushing something to the end of it and adding it. So let us use append method to append an item. What do we have in our list at this point? We have apples, banana, and cherry. What do we want to append? We want to append something called as orange. So as soon as we print this, the list becomes 4 elements and we'll have orange attached as well. However, we attached it to the end. What if you want to attach it to a specified index? Well, what if you want orange to be the second term and not the fourth term? Well, to do that, all we have to do is index it and put it at that particular index. So check out this line, guys. All we are telling Python is that put orange at our first index. Wherever index 1 goes, orange goes there and rest gets appended here. So as soon as we go print this, we'll get apple, orange, banana, and cherry. As you can see, perfect. So next up, can we remove an item? Well, yes. The remove method only removes the specified item. So let's say this list.remove of banana. Well, what happens? Can you guys take a guess? Well, definitely for starters, banana gets removed. But what happens to cherry? Does cherry remain or cherry go? Well, guys, definitely cherry remains. It just gets appended to apple in this particular case. So check that out. Apple and cherry remain. However, guys, there is a method called as the pop method, which removes the specified index or the last item if an index is not specified. So let's just say pop, and we haven't specified a particular index in this case, right? So as soon as we do this, our last element, which is cherry, goes away. So we'll get apple and banana. And moving on, we have something called as the del keyword, guys. So del, as the name suggests, is used to delete. Well, this keyword is used to remove a specified index. So in this case, we're removing the reference to the particular point at the index 0. As soon as we go ahead and run this, apple is not indexed anymore. So we have banana and cherry. And the delete keyword can also be used to delete the entire list. So del this list will actually remove the entire list. This will cause an error. So let us check out what the error actually is. As you can see, we have a name error which says that the name this list is not defined. Why is it not defined? Because we use the del function to actually delete it. And next up, we have something called as the clear method. Clear method is basically used to empty the list. This list, we have apples, bananas, and cherries. So clearing this list will print an empty list for us. As you can see, we will have nothing in the output and it is just an empty list for us. So can the list exist at an empty state? Well, as you can see for yourself, it can. Also, lastly, we have something called as the list constructor. Well, it is also possible to use the list constructor to make a list for us. And using the list constructor, let's make a list right now. So basically, we have this list is equal to list. We have apple, banana, and cherry. Make sure that when you're using the constructor, you're using double parentheses and not the square brackets, right? But this gives us the same output because eventually at the end of the day, we're making a list again. So as you can check out, the output is with square brackets, but the input isn't. If the input was with square brackets, then it becomes a normal list. It is not the constructor that is doing the job for us. And now that that's done, let's head back to our presentation to check out what's next. So last thing about list you guys need to know is all of the methods, right? So I've attached almost all of the list methods here and check them out. We have append, we have clear, we have copy all the way until sort. Well, append adds an element to the end of the list, clear removes it, copy returns the copy of the list, count returns the number of elements, extend is used to add elements at the end of it, insert is used to add an element, and pop is used to remove the element at a specified position. However, if you guys can remember, if no position is specified, it removes the last one. Reverse is used to reverse the order of a list, and sort automatically sorts the list in the ascending order. So that's all there is to know about lists, guys. So let's check out what's next. Well, we have Python tuple, and let's head back to our code. I'm pretty sure the approach we're taking to learning code is going to help you guys. So instead of just looking at theory, if you understand this with code, this will make your life a lot easier. So let's start. Well, what is a tuple? Well, a tuple is a collection which is ordered and it is unchangeable. Unlike lists, you cannot change this, guys. And Python tuples are returned with round brackets and not square brackets. So remember this, if it's a square brackets, it's a list. If it's a round bracket, it's a tuple. Well, apple, banana, and cherry followed by parentheses. So what does this give us? It definitely has to give us the output to be apple, banana, and cherry. So can we access the tuple items as well? Well, we can access it, and in this particular case, what are we doing? We're printing out 1, right? So in this particular case, what we're doing is we're indexing 1. What exists at index 1? Apple is 0, banana is 1. So we got the output to be 1. And next up, can we change the tuple values similar to the list value? Well, no. Once a tuple is created, you cannot change its value, guys. So tuples are unchangeable unlike lists. So let's check out the code here. We have apple, banana, and cherry, and we're trying to replace banana with blackcurrant. However, will that change? Let's see what happens. Well, it will throw an error for us and tell that the tuple does not support item assignments. but the value remains. So what happens when you print the tuple without doing any changes? It will still remain as apple, banana, and cherry. We hope we're clear with that, right? So next up, we need to know how we can loop through a tuple. So similarly, we'll be using a for loop and we'll be printing the elements in the order as discussed earlier as well. So as soon as we go and run this, we'll have 3 separate elements, apple, banana, and cherry using the for loop. Don't worry guys, we'll be discussing for loops in just a while. And next up, can we check if an item exists, right? So we can check if apple exists in our case. Again, as similar to the old one, if apple exists, print. If apple doesn't exist, at this point of time, our interpreter has no clue what it has to do. So it will tell you apple exists because apple exists. However, if you just ask blackcurrant at this point, it will give you a blank output and it doesn't know what to do. Can we solve this? Yes, we can. I'll be discussing this in a while as well. And next up, can we print the tuple length? Definitely, it is as similar to our list as well. So all we have to do is print len in this tuple, and as you can see, 3 elements, so the output is 3. Can we add elements to our tuple? No, as I previously mentioned guys, this is really important, so I have put it twice. So make sure you check this out and that gives you an error. I've had a lot of people who come to me and show me this error and ask me why this happens. Well guys, Python is built this way. There are multiple uses of tuples which will not require a change in the value. Well, you will know more about why tuple is immutable in the future slides as well. But make sure to remember at this point that you cannot add items and you cannot delete items from it as well. But if you cannot add and if you cannot delete the elements, can we delete the tuple completely? Well, yes, the del keyword can be used to delete the tuple completely as well. So let me go ahead and run this. As you can check this out, now we have a blank output. It says that this tuple is not defined. Why? Because we actually deleted it. So next up, we have something called as a tuple constructor, similar to the list constructor. It is possible to do it. Make sure that there are double braces here as well. So let me go ahead and run this and it'll create the tuple for us. As you can see, apple, banana, and cherry. That's pretty much simple as that, right? So let's head back to our presentation. So guys, we have 2 tuple methods again. So what are the methods we have? So we have count and we have index. Well, what does count do? Well guys, count returns the number of times a specified value occurs in a tuple. So if there is apple and you want to count how many times apple has occurred. So let's say you have 3 apples, apple, apple, and another apple. So 3 elements of your tuple. As soon as we run count on that particular tuple variable, we get 3. Why? Because apple is specified for 3 times. What if apple doesn't exist at all? Well, it'll give you an output to be 0. Same thing for index as well. It searches a tuple for a specified value and returns the position to where it was found. So we have apple, right? So we have apple, banana, and chocolate. Let's say we have apple, banana, and cherry. So if you guys can recall, where is banana? Banana was the second term. What is the index of the second term? 2 minus 1, which is 1. So banana is in the second term, but the index is 1. Make sure you take a note of this, guys. I hope I'm really clear with all of the concepts. So let's check out and dive back into more of code with Python sets. Well guys, what is a Python set? Well, a set is a collection which is unordered and unindexed as well. So there is no indexing and it is not ordered as well. So it is written with curly braces, unlike parentheses and square brackets in the case of tuples and lists. So make sure you remember that. However, let's begin. Can we create a set? Yes, we can. So how do we create a set? We make use of curly braces for that. So let me go ahead and run this and it is supposed to give us the output to be cherry, banana, and apple. Perfect. Can we access the elements of a list? Yes. Here is something different, guys. You cannot access an items of the list by just referring to an index, right? Because it is unindexed. Well, what does that mean? Sets are unordered. So Python will have absolutely no idea where your value is. But how do we get a value if we actually need one? Again, we can loop through the entire thing using a for loop, or we can ask if a specified variable is present in the set by checking if it is present using the in keyword, guys. So let's go ahead and use the for loop for now. As soon as I run this code, we're iterating through it and we're printing X. So what are we printing? We're printing cherry, banana, and apple using for. And as you can notice with this set, this is not being printed in order, but it is printed in the descending order. So we have cherry first, banana, and apples later as well. So make sure you take a note of this. And guys, let's make use of the keyword in now. So what happens if we use in? Is banana in this set? Well, yes, it is. We know that. Does Python know this? As soon as we run this code, Python does know it. So this gives us a binary value to be true, or it gives you a value to be false and nothing else. So banana is present in this, so it is giving you true. Well, let's play around. Can we make this bananas and check if bananas is present? As soon as we run this, it is supposed to give us false. Why? Because we have bananas in our set and we are printing for banana. I hope you guys are clear with that, right? The next big important thing about sets is that you cannot change items once the set is created, but you can add new items to it. So how do we add items to a set? We have a method for that as well. We call it the add method. Guys, do make sure that for every method we have something called as the parenthesis which follows that, and the expression or the values that is passed into that method is given in those parentheses, right? I'm pretty sure all of you guys are following until this point, so let's quickly go ahead and check out how we can add. Well guys, this set we have apple, banana, cherry. We're going to add orange here as well. So as soon as I print this, orange is supposed to be added to the last. As you can see, cherry, banana, apple, and orange is added to the last. So can we add multiple items here as well instead of adding single items at once? So what if you want to add 100 items? Do you have to do it 100 times? So we can use the update method and push all the values that we need to do it, and eventually it'll be added to our set as well. So check this out. So we have cherry, banana, we have mango, orange, grapes as well. So as you can see, it is unordered and it has been put and our values are established here. Can we get the length of the set? Similarly, yes, we can do it. All you have to do is use the len method. So let me go ahead and print this. We got 3. Can we remove an item? Well, removing can be done in 2 ways. So we'll be using remove method or using the discard method. Let's use the remove method and let's see what happens when you remove banana. As you can see, cherry and apple. However, do note that if the item you have to remove does not exist, remove will raise an error, guys. So let's see what happens when we try to remove banana using the discard method, right? So what happens when we discard something? Well guys, apple, banana, cherry, the same example. We have discarding banana at this point. Let me go ahead and do this. Obviously, we'll get the value to be cherry and apple. Banana is gone. So if the item we are trying to remove does not exist, we will not get an error in this particular case, right? So discard will not give us an error, unlike remove. Remove method will give us the error, but discard method will just process it and tell you that it doesn't exist. That's about it. However, we can remove an item in another way. We call this the pop function, guys, but this method will only remove the last item and not the indexed item. However, with sets, you anyway cannot index it, so it won't make sense. So yes, sets are unordered, and when you run the pop method, you will not know what item gets popped. So guys, how do we clear the elements present in this set? Clear method, as I previously explained. Done. We have a set which is empty, and we don't have just braces, right? We don't have empty braces which might denote tuple for us. In case of a set, we have an output which says set and nothing inside of it. So guys, how do we delete the set completely now? Well, we can use the del keyword to remove the entire set for us. So as you can check out, we have deleted the entire thing and we have an error now. Why do we have the error? Because we are trying to access something that is deleted. So our interpreter tells us that this set is not defined. As simple as that. So guys, next up, we have set constructors. So again, is it possible to do it? Definitely yes. So how do we do it? Well, as simple as the name suggests, with the constructors like we previously discussed, all you have to do is put 2 parentheses together and done. So let me go ahead and run this. As you can check that out, we have cherry, banana, apple, and curly braces is to be noted because this is a set, guys. So next up, we need to check out the set method. So let's quickly head back there. So guys, we have few methods here as well. We have add, which is used to add the element. Clear is to remove it. Copy is to return a copy of the set. Discard is used to remove the item. Pop is to remove a random element from the set. Do note that the randomness of it. We have something called as a difference, right? So what does difference do? Well, it returns a set containing the difference between 2 or more sets as well. It is really simple, guys. But I'm pretty sure at this point you will not use all of these methods, guys. But make sure that you learn all of these and you know what this does, because at the end of the day, when it comes to learning Python, it is really important that you understand all of it, right? And when you're actually using it, it makes it so much simpler as well. So right, moving on, what do we have? We have Python dictionaries, guys. So again, let's get back to our code. Well, what is a dictionary? Well, a dictionary is a collection which is unordered, but it is changeable and indexed. So it stores it in no particular order, but it is changeable and it is indexed, right? So Python dictionaries is written with curly braces and they have something called as keys and values. Do know that the left side elements are keys and the right side elements are values. So brand is a key and Ford is the mapped value to the brand. As you can notice, we have opened the curly braces. Everything is in double quotes here and it is separated by a colon. So as soon as we go ahead and print this dictionary, let's see what we get, right? So as you can check out, it says brand is Ford, model is Mustang, and the year is 1964. Python dictionaries are again pretty much simple. Now that you're aware of lists, you're aware of tuples, you're aware of sets, dictionaries, you can grasp dictionaries really easy, guys. So accessing elements, again, we can access our elements by referring to its key name inside the square brackets. So instead of indexing a value here, we'll have to index the key. What are the keys? Let's go back. As you can check out, our keys brand, model, and year, right? these are the values, Ford Mustang 1964. So let's check out what happens when we get the value of the model key. So guys, as soon as you do model, it is going to print us the key, which is Ford. But however, you can use another method as well, get. Well guys, get is the same as accessing the element here as well. So you can get the value of the model key using get method, pretty much simple. However, can we change the values? Yes, you can change the values as everything here is changeable in a dictionary. You can change the value. You can change the value of a specific item by referencing its key name. So let's say we want to change the year from 1964 to 2018. Can we do that? Yes, we can. So let's just do it. So now that that's done, our year changes from 1964 to 2018, guys. Can we loop through a dictionary? Well, yes, using a for loop again. But make sure when looping through a dictionary, you make sure of the return value, right? They're the keys of the dictionary, but there are methods to return the values as well. We print all the key names in the dictionary one by one. So let's go ahead and do that. As you can see, we're running a for loop inside X and we have printed all the keys here. So what are the keys for us? Brand, model, and year. Let's print out the particular values to these keys. So it says brand is Ford, model is Mustang, and the year is 2018. Perfect. Also, we can use the values function to return values of a dictionary, guys. So let me go ahead and run this to check out what values we get. As you can check it out, Ford Mustang 2018 is the values. However, we've been looping through single elements, right? So can we loop through both the keys and the values? We can do it using the items function. So let me go ahead and run it. As you can see, brand is the key, Ford is the value. So both are attached together. So it says brand is Ford, model is Mustang, year is 2018. We changed it from 1964 to 2018, right? So we have the latest value to be 2018 here. So can we check if a particular key exists? Well, to determine if there is a specified key in the dictionary, we make use of the keyword in. So it's pretty much the same thing when compared to lists and tuples as well, so guys. So what have we done here? We have brand Ford, model Mustang, year 1964 as usual. If the model exists, print that the model exists. Does it exist? It does. Perfect. If it doesn't, our Python interpreter has absolutely no idea why it doesn't, but we'll make sure we'll teach it at this point of time. And can we get the length of the dictionary as well? Yes, we can. We're going to print length of this dic and we're going to get 3 because 3 elements are there. 3 key value pairs are there, guys. Make sure we don't get 6 because a key is mapped to a value and that doesn't add in value. So what do I mean by this? So we have brand and Ford, model and Mustang, year in 1964. However, how many key value pairs is what we are trying to print here? So we have 3 key value pairs being brand Ford, model Mustang, year 1964. So that's the perfect output. So can we add an item to the dictionary? Yes, it can be added, but we'll be using a new index key and assigning a value to it. So we have to give a value an index, right? So what is the index in our case? It is a key. So let's go ahead and add color to be red. So as soon as we go ahead and print this dictionary, we'll have a lot of details here. So we have brand equal to Ford, model equal to Mustang, year is 1964, which already existed. And we have color to be red, which got appended now. Perfect. Also, can we remove the items? Well, there are multiple methods to remove the items, and let's start out with the pop method. The pop method removes the item only with the specified key name. As soon as I go ahead and run this, we are trying to remove model here. So there you go, model is gone. However, guys, do note that there is another method called as the pop item method. Well, what does pop item method do? Well, this removes the last inserted element, right? So what was our last inserted element in our case? It was definitely color. So we have brand and model as well, and we don't have the color anymore because that was our latest entry and Python deleted that for us. However, we can use the del keyword as well. This removes the element with a specified key name. So what are we doing here? We're trying to delete model. So as soon as we go ahead and run this, our model is deleted. Brand remains, year remains, but the model is deleted. Can the delete keyword be used to wipe the entire dictionary? Well, yes. We've deleted this and this will give us an error now. Perfect. Can we have the dictionary but can we clear its values? Well, yes, you can. As soon as we run this, it is going to give us an empty dictionary with only just curly braces as output. So this indicates that the clear keyword has worked perfectly and our dictionary is now empty, guys. So next up is the dictionary constructor, same as before. Guys, do know that the keywords here are not literal strings as I previously explained. And make sure you note that equals is used rather than the colon for an assignment, right? So at all of these point of time, we're using colons because this is a key and a value pair. But here we're using is equal to because this is the constructor and not the method. So as soon as I go ahead and run this, again, we'll get the exact same output, but here the constructor is doing the job for us. Well, now the dictionaries are done, let's quickly head back to our presentation to see what's next. Again, these are some of the methods we've already discussed. We have clear, copy, we have from keys, we have update, and we have pop, guys. So make sure that you guys note all of these at this point, and this is really important. This is really important because in the future, once you're starting to code on your own, you'll be using these a lot and this will make your life simpler, guys. So that's a little bit of code we checked out, but we need to check out more, guys. So we need to check out what conditional statements are. So let's just head back to our code and check out what conditional statements are. We've already discussed this, but you actually don't know we have. So we did something called as if before, right? So what is if? Well, guys, it is a condition. Well, I'm pretty sure even if you're not familiar with this program, you can guess the output. A is equal to 33, B is equal to 200. If B is greater than A, print B is greater than A. Well, guys, check it out. B is 200, A is 33. Is B greater than A? Yes. If it is true, the interpreter heads into this block and prints whatever there is. So as soon as we go ahead and print this, it will tell us that B is greater than A. So in this case, we have used two variables, right? A and B, which are part of the if statement to test whether B is greater than A. As A is 33 and B is 200, we know that 200 is greater than 33. So we print the screen saying B is greater than A. However, as you guys check out, indentation is really important. And now without indentation, let me run a program to show you what happens. So as you can see, A is equal to 33, B is equal to 200. If B is greater than A, B is greater than A is printed. However, print is not indented under if. As soon as I run this, it'll have no idea what to do if B is greater than A because nothing is intended there, right? So as you can see, Python is simple enough to tell us that it is expecting an intended block under if for us. So that's the error, and make sure you guys indent everything. So at this point, we used a lot of ifs, right? We didn't use else. We know that if a banana exists, then print it. What if the banana exists? What's the else part of it? What if the banana doesn't exist, right? So we're going to check out that right now. We have something called as the elif keyword for that, guys. Well, A is equal to 33, B is equal to 33. If B is greater than A, print B is greater than A. In this case, is B greater than A? Well, both are 33, so that doesn't make sense. So our interpreter doesn't even go to the line which says print B is greater than A because it won't enter our indentation with B greater than A, right? Because it doesn't make sense. So it comes to the next thing. Well, if B is not greater than A, else if, what is our condition? Well, else if that is not true, what is our condition? That is what elif means. Elif A equal to B, can we check if A equal to B? As soon as we print this, we're going to get an output to be A and B are equal. So eventually our elif block is executed and not the if block, guys. But it doesn't have to be that we need to use elif all the time, right? So we have something called as the else keyword. Else keyword can be used without catching any preceding statements as well. So A is equal to 200, B is equal to 33. If B is greater than A, print B is greater than A. Is B greater than A? No. So this entire loop is not printed at all. Elif A is equal to B. Is 200 is equal to 33? Absolutely not. So this is not printed as well. So what's the last outcome? Else, if both are false, what do I do? Well, if both are false, print that A is greater than B because that is the only option. If it is not equal, if it is not lesser, definitely it has to be greater. So as soon as we run this, it is going to give us A is greater than B, and that's perfect. And in this example, A is greater than B, so the first condition is not true. Again, second was not true, but the last one was. You can also have an else without an elif. So you might be wondering if elif is compulsory to use else, right? It actually isn't. So A is equal to 200, B is equal to 33. If B is greater than A, B is greater than A, else B is not great. Well, we don't have an elif, it still works. So guys, let us dive into the specialty of Python. We have something called as a shorthand if. What is shorthand if? Well, consider that you only have one statement to execute, right? You can put it in the same line as the if statement as well. So what are we doing? If A is greater than B, we don't have to go to the next line and indent it. So if A is greater than B, just put a colon and put the next line there itself. So what are we doing? If A is greater than B, all we're trying to do is print that A is greater than B literally. So let me go ahead and run this. In our previous case, value of A was indeed greater than B, so we have the value to be A greater than B here. However, we have a shorthand for if else as well. So if you have only one statement to execute, do note that it has to be one for if and one for else. And you can put it all in the same line. Well, one line if else statement is like this. So we're going to print A if A is greater than B, else we're going to print B. So what do you think is the output? We're supposed to get A because A is greater, right? And now we can have multiple else statements in the same line as well. So our shorthand is getting even shorter for us now. So let's say we are printing A if A is greater than B, else we are printing is equal to if A is equal to B, or else we are printing B. So what do you think is the output? However, in this particular case, again, it's supposed to print A because A is greater, right? But this is just to show you that there can be multiple else parts. So guys, next up we need to check out something called as and or. Both of these are logical operators and they are used to combine the conditional statements, right? Well, let us test if A is greater than B and if C is greater than A. As soon as I run this, it is supposed to print both the conditions are true because 2 is greater than 1 and 3 is greater than 2 as well. So guys, do recall that AND will only give you the output if both the values are true. So however, in case of OR operator, only one has to be true, right? Good enough. So let's just head back to our presentation again. So guys, we need to check out looping right now. So we're talking about loops for a while, right? So we need to check out what loops are. So that's the next particular thing we'll do. Let us check out what looping is. It is definitely really easy and you guys will grasp it really fast. Check this out. So basically, Python supports two types of loops. One is the while loop and the other one is a for loop. With the while loop, you can execute a set of statements as long as a particular condition is true. So let us consider this. Print I as long as I is less than or equal to 6. So while I is less than 6, print I. However, particularly, we need to make sure we increment I. So consider this. I is equal to 1. While I is less than 6. So what is I right now? I is 1. Is 1 less than 6? Perfect. Enter the block. Print 1. Next up is increment that 1 by 1. So what happened? I is 2 right now. So what is the next value as soon as it comes here? I becomes 2. Is 2 less than 6? Yes. Print 2. So this does it until 6. Consider now I is equal to 6. Well, is 6 less than 6? Well, definitely not, right? So it won't print. The values of 1 to 5 are supposed to be printed for us and perfect. However, do note that while loop will require the variables to be ready. Well, in this particular example, we had defined an indexing variable I which was 1, so it was easier. But at this point of time, this is definitely sufficient for you guys to learn, so I've put this simple example up, guys. Next up, consider the break statement. Well, with the break statement, we can stop the loop whenever we want, if and if only the condition is true. Well, I is equal to 1, while I is less than 6. If 1 is less than 6, print 1, 1 is printed. Is I 3 at this point? No, I is still 1, so break won't work. It will come here, I becomes 2. Is 2 less than 6? It is printed. Is 2 equal to 3? No, increment it again. 3 is 3 less than 6? It is, so enter the while loop. Print 3. Is 3 equal to 3? Break. So I'm sure you guys are confused at this point, right? Well, at this point, I was supposed to be printed for 6 times. Let me go ahead and print it and it'll only come 3 times. Why? Because we have a break statement here which says when I becomes 3, remove all of the remaining iterations and just pull the values out of it. So we have I is equal to 1, 2, 3, which was the output that we got. So next up, we have the continue statement, guys. With the continue statements, we can stop the current iteration and continue with the next. What do I mean by that? Check this out. I is equal to 0. While I is less than 6, I is 0, so definitely enter it. Increment I by 1. If I is equal to 3, continue and print. Instead of breaking it, we're continuing it. So what does this do? So basically when I becomes 3, that particular iteration is dropped and then the remaining is done. But with break, if I is equal to 3, throw out everything else and come out, right? In this particular case, if I is equal to 3, good enough. Remove that particular iteration and do the remaining things. So that's about it, guys. As I told you, Python is really intuitive and it is really simple to grasp. However, next we have for loops. Again, these are very simple as well. So let's check them out. Well, guys, a for loop is used for iterating over a particular sequence. So we need something, right? So what are the sequences that we learned until now? We learned lists, we learned tuples, we learned sets, we learned dictionaries, or even a particular string. Well, again, for and while are all keywords and they are reserved. So you cannot use it for the variables as well. So consider this particular case. Right? So we have fruits as apples, banana, and cherry. For X in fruits, we are printing X. Well, what is X? X tells you how many times it has to iterate through it. In this particular case, it is 3. So what is the output we're supposed to get is, we're supposed to get apple, banana, and cherry in the particular order. Well, in the numerical part of it, X becomes 3. Well, in this particular case, X is assigned each variable as a string and then the output is printed. Well, X is equal to 3 is what we know, but X is equal to apple, banana, and cherry for every iteration is known by the interpreter, guys. However, there was one slight change with the code. If you notice that the for loop did not require any indexing that the while loop required. Well, the while loop required a particular value, right? It required I is equal to something to start out with. The for loop does not require that. However, let's go ahead and check this case on how we can loop through a simple string. Well, guys, even strings are iteratable objects, right? So basically a string is nothing but a sequence of characters. So can we loop through the letters in the word banana? Yes, we can. So let us go ahead and do that. We'll have separate elements and broken down for us. So we have B-A-N-A-N-A. Perfect. And next we have the break statement. Well, with the break statement, we can stop the loop before it has looped through all the times as we've explained earlier as well, right? Well, when X is equal to banana, just break out of the loop and just ignore whatever is left. In this particular case, cherry is ignored. So we'll get apple and banana to be the output. and exit the loop when x is banana, but this time break comes before the print. Well, what happens when this occurs? Check this out. So print comes later, right? So it's being broken first. Well, as soon as it breaks, as soon as it comes to banana, it is breaking it. When banana is break, so banana and cherry are gone. And the only thing that remains is apple. So you're printing apple at this point of time. And next, the concepts are similar with the continue statement as well. It is just that we will only drop that particular iteration and not everything else. So let me go ahead and print this. So it's basically telling it not to print banana, but print everything else for us. As you can see, apple and cherry are here. Next up, guys, we have something called as the range function. Well, to loop through a set of code a specified number of times, we use the range function. What do we mean by this? For x in range of 6, print x. Well, this particular thing will start from 0 and give us 6 values. So we're telling that we need 6 values, but we're starting it at 0. But we are not telling it to start at 0. How does it know? Well, Python interpreter knows that it has to index from 0. So it is going to give you 6 elements from 0. That is 0 to 5, guys. Again, do note that it is not 0 to 6, but 0 to 5 as I explained. It is really simple, guys. But what if we require a range which doesn't start with 0, right? So can we have a range which starts with something and gives us these many values? Well, check this out. So we have for x in the range of 2, 6. So what are we trying to do here? So we're trying to print out the range that exists between 2 and 6. So we have 2, 3, 4 and 5, but it does not include 6. So the first number is always included and the last number is always omitted, guys. Do note that. So as you can check out, we're incrementing the number by 1, right? So 2 becomes 3, 3 becomes 4, 4 becomes 5. How? We're just adding 1 to it. But what if we want to add something else? What if we want to add 3? What if we want to add 100? Well, there is a third parameter that exists for the range function and it does exactly this. Check this out. So printing elements from 2 to 30 with an interval of 3. So 3 is being added everywhere instead of 1. Are we clear with this, guys? And next up, we have else in for loop. Well, the else keyword in a for loop specifies a block of code to be executed when that particular loop is finished. What do we mean by that? You can understand this better with the example. So check this out. We're printing all of the numbers from 0 to 5 because the range is 6. And we print a message when the loop is ended. But we're only printing something which is finally finished, which is in the else part of it. So this eventually becomes the else part and it is telling that if that is not done and if the x crosses 6, what do I do? Well, when x crosses 6, you print a message which says finally finished. What if x was 7? Obviously. So anything above 6 is omitted, right? That's same here as well. And you have the last two concepts with loops. Well, one is nested loop. As you can concur from the name, a nested loop is as simple as a loop within a loop. However, you need to understand the execution order of it. The execution order is this. The inner loop will be executed one time for every iteration of the outer loop. So let's say you have the outer loop to be performing 10 operations and the inner loop to be performing 10 operations. So the inner loop works once for every outer loop working. This happens for the next 10 times as well. So consider this, guys. We have certain adjectives here. We're describing the value to be red, big and tasty. So I'm pretty sure we're talking about, again, fruits. So what are the fruits we're talking about? Banana, apple and cherry. For every x in the adjective, and there is a loop which says for every y in the fruits, print x comma y. So it's supposed to print from the inner outwards, guys. So it is printing red apple, red banana, red cherry all the way until tasty cherry for us. This is happening only because the inner loop is executed one time for every iteration of the entire outer loop. So guys, the next concept here is recursion. Well, Python accepts function recursions as well. What do we mean by that? Well, a function which is defined can call itself as well. And recursion is really a common mathematical and a programming concept. It means that a function can call itself and nothing more. This has to be benefit because you can loop through a data until you reach a particular result. So you can keep looping through something until you get to a point where you have to get to, right? So consider this example, right? So we're using something called as defined tree function. However, we are not familiar with what this line means. Well, what it actually means is we are defining a function of our own called as the try recursion, and we are passing it a value to be k. And moving on, if this value k is greater than 0, we're going to print a result by adding the k to the recursion of it, and we're going to call recursion again. Where are we calling the recursion again? It's particularly here. As you can check out, try recursion is the same name as our function, right? So if k is greater than 0, we're going to add k and we're going to call this function again. But this time the value of k is 1 less than what previously was done. We're going to print it until all of the result becomes 0. Well, what if it becomes 0, right? We cannot keep going. We need to stop somewhere. So we tell it that once the result is 0, just return the entire result for us. So as you can check out, we have 1, 3, 6, 10, 15, and 21, 21, right? Well, how does this work? Well, guys, let me tell you one thing. The best way I found out the understanding programs is by actually following through the code. Well, if you can check out the last line, it says try recursion of 6. Well, initially k is 6. Is 6 greater than 0? Yes, it is. So the result gets added and k gets added to this. So k becomes 6. And again, the function is called until this point of time where k becomes 5. Is 5 greater than 0? Yes, keep doing this and keep printing each of these, right? So after you're done printing each of these, once it becomes 0, try underscore recursion of -1 doesn't exist for us. So the result becomes 0 and we have printed the entire result. So that's about it, guys. Just make sure that if you don't get recursion at this point, just make sure to repeat the entire thing again and run through the output code to make sure how is it working. So once you're familiar with how it's running, you'll really be able to crack the code easier and you'll be able to follow through the values, guys. So guys, next up is Python functions. We already saw how simple it is to define our own functions, right? So it is definitely easier than you actually think. Let's head back to the code. Well, what is the formal definition of a function? Well, guys, a function is a block of code which only runs when it is particularly called. So there is someone who's calling our function and there is someone who's called. In our particular case, the function we write is the called part of the program. So whoever or whatever is calling the function is actually wanting to make use of this particular function of us. So we can pass data, which is also called as the parameters, into a function. Again, we've been seeing this all this time, right? So whatever we put in the bracket as the parameter, as I previously explained. However, a function can return the data as a result as well. So let's create a function, right? Let's create another function and let's do something simple. So let's print something that says hello from a function. So def is used to define, that's a particular keyword. My function is the name of it. I can have anything here as well. I can have a function which is called as Edureka. So we're printing hello from a function. So as soon as we go ahead and print this, we're going to have a function which says hello from the function. That's about it, guys. Next up, we have something called as calling a function. How do we call a function? We need to define a function and then we need to call a function. So use the following syntax, guys. Check this out. So we have defined the function, we have printed it, right? So as soon as we call this function again, which is actually going back to our function, and then the output is had. So now let me just go back and run this. However, we have defined a function and printed it as well. Why aren't we getting this particular output here? Well, guys, we haven't called the function yet, so that's the only particular reason. The syntax is perfectly all right. And next, we need to check out the parameters that we can pass to a function, right? So length was a function and we used to pass the name of the string before. So the information can be passed to the function as a parameter, and these parameters are specified after the function name inside the particular parentheses as shown here. So here fname is a parameter for the function my function, right? So you can add as many as parameters you want, but make sure you separate it with just a comma, guys. So the following example here, we have a function and we have one parameter called as fname. When the function is particularly called, we'll pass along a first name which is then used inside the function to print our full name. So let's check this out. We have three names that we are passing, right? For fname, we have three names. One is Emil, one is Tobias, one is Linus. However, what we're trying to do is we're trying to attach this fname to something else. So we'll have Emil ref census, we'll have Tobias ref census, and we'll have Linus ref census. Check this out. Perfect. But here we were particularly specifying a value, right? But what if we don't? What is the default parameter value? Check out the following examples. So if we call the particular function without a parameter in it, it uses a default value. So guys, check this out. We have a function with the name my function. Country is supposed to be Norway, which is already printed for us. So we'll be printing I am from and we'll be attaching our country. So it says I am from Norway. But it doesn't have to be Norway all the time. It can be Sweden, India, and nothing, right? Check this out. Check the output, guys. It is pretty much interesting. As you can check out, when nothing is provided, we're printing Norway. When something is already provided, when a parameter is already defined by our calling function, then use that. So here we're using Sweden, so Sweden gets printed. Here we're using India, so it says I am from India. Here we're not using anything, but default value is already specified to be Norway. So when nothing is specified, make sure you use Norway. And again, we have Brazil specified, so Brazil comes out, guys. It is as simple as this. So next up, we need to check out return values as well. So what is a function returning and what is a return? Well, return is used to print and pull a value out of our function, guys. It is as simple as that. Check this out. We're defining my function with the parameter to be x, and we're returning something and we're multiplying that particular value of x with 5. However, what are the values of x that we're providing? It is provided by these numbers, right? So we have 3 into 5, we have 5 into 5, and we have 9 into 5. And the product of all these are printed to be 15, 25, and 45. It is as simple as that, guys. So guys, next up we need to check out something called as the arrays, right? Arrays are really simple and straightforward, and let me walk you through arrays really quickly here. So what are arrays, guys? Python does not have a specialized support for arrays, but Python lists can be used instead. Well, lists are nothing but arrays, to be honest. Well, check this out. Cars equal to Ford, Value, and BMW. Well, check this out. Cars is Ford, Volvo, and BMW. Perfect, right? This is nothing but a list. But what is an array? Well, an array is a special variable which can hold more than just one value like a list at a time. If you have a list of items, so let's say a list of car names, for example, storing the cars in a single variables can look like this, right? So car 1 is Ford, car 2 is Volvo, car 3 is BMW. However, if you want to loop through the cars, how do you find a specific one, right? And consider this. What if you had over like 1,000 cars instead of just 3 cars, right? How would you do it? The solution is an array, guys. The array can hold as many values under a single name, and you can access the values by referencing the index number. Let us access the value for now. So let us access the elements of an array right now. So basically we're indexing it with our index number. So cars of 0, as I previously checked out, what was cars of 0? Cars of 0 is Ford. So as soon as we run this, so X is assigned to cars of 0, which is Ford. So X is Ford right now. But can we change it? Yes, cars of 0 instead of Ford, we can put it to be Toyota. So as soon as we run this, it is Toyota. Can we find the length of the array as well? Yes. So X equal to length of cars, right? So as soon as I go ahead and run this code, print X, X is 3. That means that our cars is an array with 3 elements inside it. As simple as that, guys. So how do we add array elements? Well, guys, it is really simple. As we previously discussed, there's something called as the append method. So we already have 3 elements in our array. So as soon as we run cars.append.honda, Honda becomes our 4th element. It is as simple as that. Can we remove the elements? Well, yes, there are 2 methods to remove, and one is the pop function, one is the remove. Do note that when we use the pop function, we send the index to it, but when we use the remove function, we name the value of it. So the element which says Volvo and it has a value to be Volvo is removed. However, both is doing the same thing, but we have the index here and we have the value here, and that is really important for you guys to note. So now that we've checked out, we have some of the array methods that I really want you guys to take a note of. So let me just go back to my presentation and we can check out our array methods, right? So as you guys can check out, these are some of the array methods that I want you to note, right? So there are clears, there is copy, there is count, there is insert, pop, remove, reverse, and sort as well. So moving on, we need to check out something called as classes and objects, right? So we told that Python is an object-oriented programming language. Well, what are classes, what are objects? And that is exactly what we're going to discuss right now. Well, we've already discussed that Python is an object-oriented programming language, and almost everything in Python is an object, right? But it has properties and methods as well. A class is an object constructor, or it is also called as a blueprint because it contains details of this particular class for us, right? So guys, check this. We're going to create a class which is called as my class, and it is followed by a colon. It has a property which is called as X. We don't call it values anymore, but we call it as properties now, guys. So let's go ahead and create an object. Well, we can use the class named as my class to create our objects for us. Well, consider this. P1 is equal to my class, correct? P1.x is the property where we're printing the value of X. So as soon as I go ahead and print this, it is supposed to give us 5. Why? P1 is referencing to our class, but P1.x is referencing our class where value of X is equal to 5. Hence, P1.x is giving us a value 5. And next up, we have something called as the init function, guys. Well, the examples above are classes and objects in their simplest forms, right? So those were really simple examples that I gave you. But what happens when you try to use it in the real life? Well, to understand the meaning of classes, we have something called as the init function. All the classes have a function called as init, which is always executed when the class is being initiated, right? So guys, we've mentioned that Python is an object-oriented programming, right? Well, almost everything in Python is considered to be an object with its properties and methods. Well, a class is actually like an object constructor or the blueprint for creating objects, because every object gets all of its information from its particular class, right? So let's check out on how we can create a class, and you'll have a better understanding of the definition, guys. So guys, we'll be using the keyword class to create a class, and this keyword is a reserved keyword, guys. So make sure you remember that. So here we're creating a class called as my class, and we're sending the value to be 5. How can we create the object? Well, it's pretty much simple. We have a variable which references to that particular class, and then we can print something. So let us go ahead and define our class and then define X is equal to 5. So as soon as we print whatever our object holds, it's supposed to be 5. Well, why is it 5? Well, P1 is the object which points to our class. In our class, we have a value x is equal to 5, and this x is being attributed to our object P1, guys. So it's pretty much simple and straightforward as that. And next up, we need to check out something called as the init function. Well, all of the examples of the classes and the objects are in the really simplest form, right? So what I showed you is really a basic introduction to it. Well, this really cannot be used in any of the real life applications. To understand the meaning of classes, we need to understand the built-in init function, right? So all classes have a function called as init, which is always executed when the class is being initiated for the first time, guys. Well, we use the init function to actually assign values to object properties or other operations that are necessary to do when the object is being created. Well, guys, let us create a class actually. So this will give you a better understanding of the concept. So let's create a class named person using the init function to assign the values for the name and the age. So as you can check out, class name is person. We have defined the init function and we have a variable called as self for self-referencing. We have name and age as well. Well, do note that only the first parameter has to be self-referenced in all of the particular cases. More on this in just a second, guys. So we have self.name equal to name, self.age equal to age, and P1 is our object and it is referencing to our person and it's passing the value John and the age to be 36. And at the end of it, our object is printing out the name and the age as well. So as soon as I go ahead and run it, we're supposed to get the output John and 36 because John is the name and 36 is the age that P1.name and P1.age are actually pointing to. Well, that's good enough, right? Guys, do note that the init function is automatically called every time the class is being used to create every new object of us. And in this particular case, we only did it explicitly to show you a few further examples down the line. But it is actually intuitively called and it doesn't need to be done explicitly by the user. So next up, we need to check out something called as the object methods, guys. Well, objects can also contain methods, right? I'm pretty sure you guys were curious about that. And methods in objects are functions that belong to that particular object. So let me repeat. Methods in that particular object are the function that belongs to only that object created under that particular class, guys. So to understand this better, let us create a method in the person class. Well, let us insert a function that prints a greeting and then executes it on the P1 object. So we have a class called as person. We have defined the init function with the self-reference, name and the age. We have defined a function of our own called as my function. And we're defining the self-pass value as well. We'll be printing hello my name is and then appending the value of whatever the self.name actually has. So where is the value being got from? Well, we have created an object called as P1 and referenced it to our class person, right? And the value we are passing is John and 36. So as soon as we call our object method, it is supposed to pass the values of John and 36 to our function from the eventual class. So as soon as I go ahead and run this, it is supposed to say hello my name is John. Perfect, right? So guys, I have another side note for you. So the self parameter is just a reference to the class instance and it is used to access the variables that belong to that particular class and no other classes as well. So make sure you note that. And moving on, the self parameter, right? So we're talking about the self parameter a lot. Well, what is it? The self parameter is just a reference for that particular class itself and not to push out the reference to any other class as well. It is used to access the variables that belong to that particular class as I previously explained, guys. Well, it does not have to be named self, right? You can call it whatever you want. I can call it Edureka or anything, for example, as well. But guys, do note that it has to be compulsorily the first parameter of any function in the class. Let us say we'll be using the words my silly object and ABC instead of self, right? So again, we have a class function. We are defining the init method. Instead of self, we have my silly object. We have name and age. So my silly object.name equal to name, my silly object.age equal to age. Perfect. Is this correct? Yes, it's perfectly valid. And we're defining a function which is called my function. We'll be passing the parameters ABC. So here we'll be printing hello my name equal to abc.name, right? So ABC needs our value to be John in this particular case. So when we create our object P1 equal to person of John, 36, and then the object is calling a function which eventually leads to the output. So as soon as I go ahead and run this, ABC and my silly object will be pointing to the same object and eventually we get the same output to be John. Lastly, can we modify the object properties? Yes, we can set the age of P1 to be 40, right? All we have to do is we have to call P1.age equal to 40. Can we delete the object properties? Definitely yes. We can delete the age property from the P1 object by using del. Del is the keyword again as we previously discussed. Del P1.age will delete the entire property. But can we delete the entire object? Well, yes, you can delete the entire object by just using the del keyword by just calling del P1, guys. It is as simple as that. So let's quickly head back to my presentation to conclude the session. So guys, I'm pretty sure that was a lot of information for you guys to take in. So make sure you check out the timeline in the description box below in case if you're stuck with any concept or you need to relearn the same thing. So however, it is at this point of time I'd like to tell you guys that at Edureka we have multiple blogs, we have videos, and we even have a master's program on Python, guys, so you can get certified on Python as well. I'll make sure to leave the course link in the description box below, so I'm hoping you guys will check out that as well. So that is about it for this in-depth session, guys. I hope you took away some real good points from here and that this helped you kickstart your Python learning. So thank you guys, you know what to do. If you have any queries, leave a comment and subscribe to our channel for more information on the latest technologies and the courses offered.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!